Hi and welcome back to the Lab 9 of EE542 under Professor Young for 2018. This lab is based on machine learning and deep learning, where we go through the tutorials on AWS to see what we can do with machine learning and how we can carry forward the knowledge that we learned for our future and final project. The objective is to run an algorithm which could identify fake notes from the samples provided by UC Irvine. In this, we import the data, select one of the popular machine learning algorithms, train the model using the data, and then test the model. Banknote authentication dataset. It is provided by UC Irvine in one of their machine learning repositories. The dataset contains 1,300 rows, which has 5 different attributes such as skewness, entropy, variance, class, and kurtosis. Based on these 4 attributes and 1 key, we try to identify which banknote is fake or not fake. We make use of AWS Sagemaker to run our algorithms. AWS Sagemaker provides a fully managed platform that enables developers and data scientists to build, train, deploy machine learning algorithms at any scale, which could, basically scale automatically depending on the computation. It also provides us with one-click training and deployment services. The way it works is it creates a EC2 instance, and on that we create a Jupyter notebook for our implementation.
So now let's start with the first part. Over here we are given the bank authentication dataset, which I can download from here. I have already downloaded that on my system. The data has 1372 instances, with each instance having 4 features and 1 label, which is forged or genuine. Now we have to perform 3 tasks. In task 1 we have to make scatter plots of features using different colors to represent class 0 and class 1. In the second task we have to select our own machine learning algorithm, and using that we have to select the first 200 rows of class 0 and class 1 as a test set and use the rest of the data as the remaining training set. And then using that we have to report the training accuracy, test accuracy, and test F score. In order to do that, the first step is to make a SageMaker. So I'm going over here. We create a new notebook instance. And we have to create a new IAM role, but as I have already done this before, I already have execution role, so I'm going to select that. Here are the steps which I followed while doing it for the first time. As it shows, create a new role from the IAM role drop down, which I did, and I'm going to create and in the IAM role which I have selected, I have used any S3 bucket so that I can use any S3 bucket from my AWS console where I have uploaded the bank authentication set. This should be created in a while. I have already used lab 9 before, which used any bucket, so we can start with this. I did the steps just to show that this is how it is done. Now we'll start with this one. Meanwhile, we can go through the rest of the steps. As it shows, it will be once it is created, we can open it. and then we are going to select Conda Python 3, on which we are going to write the whole code. These are the libraries which have to be imported. This is for the IAM role. I have already followed all these steps before. So in the lab 9 notebook instance, all this is already done. What I'm going to do is directly start with the Python code to create a scatter plot from the data. Before doing that, I need to create a S3 bucket and upload the bank authentication data node over there. So on creating the bucket, I will upload the bank authentication data node set, which is on the desktop. Once it has been uploaded, I can use this from the SageMaker. Let's see if the notebook instance is ready for us to use. Okay, both of them are in service. I'm going to launch the lab 9 instance. As it shows, I have already uploaded lab9 data.csv over here so that I can directly use it. I'm going to launch the Jupyter notebook. Now using these libraries, I have imported few libraries, which is pandas, numpy, SageMaker, and these are the steps which I followed from the link which was given to us. Exact same steps. After defining IAM role, I created a bucket which was lab9 Phoenix, and using this I got lab9.csv, and as it shows, it was downloaded and it was loaded into a data frame. Using Seaborn library, I created a SNS scatter plot. I used pair plot because we are given two classes, class 0 and class 1, and we have to do permutations of those classes. It would be one in like first feature and second feature, first feature with third feature, first feature with fourth feature, second with third, second with fourth, third with fourth. So in total there should be 6 scatter plots as shown over here. Using this command and I have shown the two classes with different colors. Blue indicates class 0 and green indicates class 1. After doing this, after creating the scatter plot, the next step is to select the first 200 rows of class 0 and first 200 rows of class 1 and use that as the test set and the rest of the data as the training set. In order to do that, I've used .head function to extract the 200 entries and have stored that in data 0 200, and I've stored the remaining data of class 0 using .tail function in data 0 underscore remaining. I have done the same for class 0 and class 1 as shown over here. After doing that, I have concatenated the data 0 underscore 200 and data 1 200 in frame 1 and the remaining of the data in frame 2. And then I have trained both. So in order to do that, I'm going to run. As it shows, it has been trained. Now just to be sure, we can print to know that it worked. As it shows, we have been able to do that. Okay, the next step is selecting a machine learning algorithm and using that on the training and testing dataset. Now I have used KNN machine learning algorithm. To do that, first we have to import sklearn metrics, and in order to get the accuracy score as well as the F1 score, I imported accuracy score and classification report from sklearn. From sklearn.neighbors, I've imported kneighbor classifier, which is the KNN algorithm. On running this command, I'll be able to use the algorithm on the data, and as it shows, we got a test accuracy of 1.0, precision of 1.0, and a F1 score of 1.0 as well. In order to get the train accuracy, I'm going to run this. The train accuracy is 1.0 as well. So this concludes the first part, which was doing all the tasks using AWS Sagemaker. On getting over with the first part, we terminate the notebook instance, so that we do not get charged with extra credits.
Learning AMI. So deep learning is loaded with a deep learning frameworks like TensorFlow, Caffe, and etc. These all frameworks which are there are actually used for building models and training and working with really large data sets. So let us get started with the tutorial. Alright, so launching an AWS Deep Learning AMI. It's pretty straightforward. First, we need to open the EC2 console. Then we need to configure the instance. After that, we need to select a AWS Deep Learning AMI, Ubuntu. We need to specify the GPU-based P3 instances, where we are using the C5.large instance. After that, we have to create a key pair. The key pair is created so that our download the private key which is downloaded, we have to save it to a safe location and then launch the instance with it. So whenever we want to access the instance, we use the key to access it. After that, we'll get a public DNA. We have to connect to our instance. So for connecting, we open the command line terminal and we link our private key to our instance. After which we get a URL. We open that URL, which opens the Jupyter Notebook. After these steps are done, we need to perform some 3 tasks. The first task includes to make these scatter plots. Then we have to select a good machine learning algorithm. And then we need to build a model based on the algorithm, test it, and check what's the training accuracy, test accuracy, and the test F1 score. So let us get started. Here's my EC2 console. I need to launch an instance. As we saw in the directions, we need to select Deep Learning AMI Ubuntu. After that, we need to go in and we need to select a GPU-based P3 instance, which is C5.large instance. We select that, review and launch. This is a review state, so you can review whatever parameters that you have selected and launch your instance. I have already created a key pair, so It's my key pair. I acknowledge and launch instances. View instances. Now it's in the pending mode. Once it comes as in the running, you will view the public DNS. So I copied this public DNS. Now we need to go into our command line to execute this code. We need to make sure that the downloaded key, which I just showed you, my key pair, has to be linked with our instance DNS. So the DNS which I just showed you here, this is supposed to be linked with our private key. This allows us to access our Jupyter notebook. Hence, as shown, we have already done that by running this command here. As you can see, there's a different command for Windows, which is given in the tutorial if you are working with Windows, and it's pretty straightforward. You will need to access it using putty. Now, as I told you, after we're done with this, after we link it, we need to run this command, Jupyter Notebook. After running this command, we will get a URL link, and once I open the URL link, this is what opens. You get a Jupyter TensorFlow notebook. So this is my code, which I'm going to explain you really quick. So first I need to import the libraries. We're using the pandas and the numpy. We're also using the seaborn for scatterplot. TensorFlow is as the TF. Then import the dataset. So the dataset is which was already given to us. It's a CSV file, so it is imported into this dataset. Then we need to rename the class attribute to authentic to make sure that the class, which is 01, is authentic. Then we need to create a forged attribute and scale the features. Then we need to set some parameters like learning rate is 0.01, training epochs is 100, batch size 100. Then we need to show the neural network parameters. Also, this is really important. This is a multi-layer perceptron. We're using the multi-layer perceptron as a neural network, and we are setting the weights, biases, creating a model, as you can see here, and initializing some important variables. Then this is just a simple calculation to find out the accuracy, the precision. So let us see. I've already made sure that I have done this before, and I've just made it ready for execution to run it. So this is a success, which means the data has been loaded into the frame. Run again. So as I'm not getting any errors, this is just the initialization part. This is where my multi-layer perceptron is being run. So as you can see, everything is being executed quite nicely, and I'm getting this epoch where I'm getting 100 epochs and their cost for it. And so the tensor framework. Now here's the important part. As I have run the code in the proper manner, I'm getting the accuracy as 1.0, which is accurate. And the proof is that the training accuracy is 1, as shown in the graph. So this concludes the end of the deep learning AMI. Let us see the last part of the keynote presentation to ensure that we have covered all the parts required by the experiment. Right, so the deep learning AMI, as I mentioned below, our main job was to detect fake notes using an artificial neural network. We built that using TensorFlow. So TensorFlow is nothing but a open source software library. It is being used by many companies like Google. I know Google is the one who has invented the TensorFlow, but there are many other companies which use it as well. Then it can run, the main advantage is that it can run on multiple CPUs and GPUs, and it allows the flexible architecture, which is really important in today's generation when we have so many choices to pick from. The EC2 instance, we created the key, and I showed you how it was linked with their instance. We can see here that we achieved an accuracy of 0.99, and the training accuracy, the test accuracy. To be frank, sometimes it varies, sometimes it doesn't. So thank you. This concludes the Lab 9 presentation and our Lab 9. If you like our video, please like and share this and do subscribe. Thank you.